Hi guys, welcome to the third grade math lesson for this week. In your folders on Friday, you have not only the math pages for this week, but you also have a multiplication chart similar to the one that I have drawn on the board behind me. So what I would like you to do, because last week we started talking about multiplying with 0, 1, 2, 5, and 10. And we found that there's some pretty simple patterns with that. And so I want you guys to go ahead and fill out your multiplication chart with the facts that you already know. So we're going to take a little bit of time with that right now. So first of all, 0, we know that any number times 0 is going to be 0, because it's like saying I have 0 groups of however many. I have 0 groups of 10. Well, if I have 0 groups, then I don't have any groups. Or I have 10 groups of 0. So I have 10 groups with nothing in them. I still don't have anything. So any number times 0 is going to be 0. That's the identity property of 0. We also talked about another identity property, which is for 1, that any number times 1 is going to be itself. So for example, if I have 5 groups of 1, I have 5 altogether. If I have one group of 5, then I still also have 5 altogether. So we're going to go ahead and start. I'm going to zoom in just a little bit with our 1 column. So on your multiplication chart, the way that you can read it is you have numbers along the top and numbers along the sides. And you're going to create, so this is working kind of, we're going to kind of work like finding a point on a map. So we're going to find R1 and then R1. So if we have 1 and 1, our multiplication factor would be 1 times 1. We know that any number times 1 is going to be itself. So 1 times 1 is going to be 1. So I'm going to write it right in that first top corner. Now, if I move along my edge this way, now I have 2 times 1. 2 times 1 is going to be 2. 3 times 1, 3. 4 times 1, 4. 5 times 1, 5. 6 times 1, 6. 7 times 1, 7. 8 times 1, 8. 9 times 1, 9. 10 times 1, 10. Okay? So now I've filled in that first row under my top row of numbers. Now I'm going to do the same thing down the side. I still have 1 times 1 is 1. Now I'm going to go down 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9, and 1 times 10 is 10. So far, we've filled in one column and 1 row with our 1 stack. So we know all of our 1 stacks. Now we're going to go ahead and move on to 2s. So we have 2, and we're going to do the same thing. I have 2 times 1 is 2 in both places. Now I'm going to say 2 times 2, 4. 2 times 3 is 6. And we're starting to see that pattern. I'm counting by 2s, right? 2, 4, 6. So my next one's going to be 8. 2 times 5, 10. 2 times 6, 12. And we're also thinking of our double stack. So 6 2 times, or 6 plus 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. And 2 times 10 is 20. And I'm going to go ahead and do the same thing down my row. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And you'll notice that each time, if I'm counting by 2s, it's like I'm adding on 2 more, right? So 2 3 times would be 2 plus 2 plus 2. I'd have 2 3 times, or I would have 6. Okay, so now we're going to go ahead and focus on 5 and 10 as well. Now, my goal with you filling in a multiplication chart is for multiple reasons. There's multiple motivations here. One is I want it to be a future tool for you for using, for working with your multiplication facts. So in the future, if you have trouble remembering some multiplication facts, you will have all of the facts that we've already learned already filled in for easy reference. The second reason is that I want you to see, as we learn them, how many facts you really know. Because again, if you know 2 times 1, then you also know 1 times 2. So a lot of the facts will work, remember, both ways. That's that commutative property. Order doesn't matter. When we multiply, we get the same answer. So you know a lot of facts already. The last reason is there's scientific evidence that if you write something down, it helps you memorize something. And multiplication facts are one of those things that is helpful if you can memorize them so that you can recall them really quickly. We give you lots of strategies, or I should say, I give you lots of strategies because that allows you to fully understand how multiplication works, and also to find the answers that maybe you're not so sure about. Because what happens with multiplication is, like with so many things, if you're not using it, then you're probably losing it. So if you don't use multiplication facts every day, then some of those facts might get kind of rusty and you may not be as familiar with them. There are certain facts that I know by heart, and then there are other facts that I'm a little shakier on and I have to give it a little bit more thought. So it's good to have a lot of strategies in your bank, but memorizing them is also going to be a way that is really going to help you as you continue working with multiplication down the line to do things quickly and also accurately, hopefully. So by writing it down, we're also kind of committing it to memory. Okay, so let's get back to filling out our chart. Already, we have a fair amount of our chart filled out already, and we haven't even filled out 5s and 10s yet. So let's go ahead and go to 5. Remember, with 5s, we also have a pattern of skip counting by 5. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And we can double check that because 5 times 1 is 5, 5 times 2 is 10, 5 3 times would be like 3 5s, 5, 10, 15. So we can skip count to find that. We're also seeing our pattern here as we continue to add 5 on each time. So 15 plus 5 is 20, plus 5 is 25, plus 5 is 30 as they continue on. And also, oh, no, I lost it. Also, counting by 5, we can also think of it like the face of a clock. So when your minute hand is pointing to the 2, it's 10 after the hour. If your minute hand is pointing to the 3, it's a quarter past. If your minute hand is pointing to the 6, then it's 30 minutes past the hour, right? So our clock face also goes in increments of 5. And so 5s are kind of a cinch for that reason. All right, so let's go ahead and fill out our 5s column now. So we have 5, 10, 15, 20, 25 is already written in, 30, 35, 40, 45, and 50. Okay. Now we're going to go ahead and fill in our last column so far, which is going to be 10. So I'm going to start with my 10s row actually. So again, skip counting by 10s or adding on 10 more each time. 10, 20, 30, 40, 50 is already there, 60, 70, 80, 90, 100. And then I'm going to do the same thing for my 10s row. 10, 20, 30, 40, 50, the next one is 60, 70, 80, 90, and my next one is 100, which is already there. Now just take a look and notice how many facts you already know. There's only a few blocks left for you to go ahead and fill in. So already you know a lot about multiplication. Remember too that you also know that if you flip-flop your order, you still get the same answer. So if you don't know what 6 times 2 is, you can think about what 2 times 6 is. And you know that because you can go ahead and count by 2. So next what we're going to do is we're going to be focusing on 3, on ways to multiply with 3 and that the only one that we're doing? Excuse me while I consult my all-knowing resource. 3 and 4. So we're going to be focusing on learning our 3s and 4s multiplication facts. So right now, let's go ahead and switch gears from our multiplication chart. We're going to switch to our packet and start working with our understanding of multiplying by 3s and 4s. So I'm going to go ahead and take my camera all the way over to the other side, right over here. So when we have our multiplication by 3, so first of all, let's go ahead and you're going to turn to page 131 in your packet. So actually, you're going to turn to page 132, sorry. 132 in your packet. So you'll see at the top, it says, Nadia hangs her photos on the wall. She makes 4 rows of photos with 3 photos in each row. How many photos did Nadia hang on the wall? So I've made a poster here. It says Nadia's pictures. So again, we have 4 rows, 1, 2, 3, 4 rows. And each row has 1, 2, 3 pictures in it. So we can think of this as repeated addition. I have 3 plus 3 plus 3 plus 3. And I can think of that as, I know that 3 plus 3 would be 6. Add 3 more on, 6, 7, 8, 9. Add 3 again, 9, 10, 11, 12. So my answer is going to be 12. I can also break it apart and think about I have 4 in one column. And I have 4 2 times in the other. So I know that 4 times 1 is going to be 4. I know that 4 2 times is going to be 8. And then if I add them together, I have 4 1 time is 4, 4 2 times is 8. 8 plus 4 would be 12. Now, what we just did here by breaking apart our problem is another property of multiplication. It's called the distributive property. Distribute means you are breaking it apart into different groups, right? So when you are using the distributive property, you're breaking up your problem to make it easier. So instead of saying I have 4 3 times, I said that I have 4 times 1 and 4 times 2. And I know that 1 and 2 together make 3. So if I add up my answer, I'm going to get the same thing as 4 multiplied by 3. Okay, let's go ahead and move on to the next problem. So you'll see on page 130. Hi, Malik, I'm recording a math lesson right now. I'll see you later, okay?
Okay.
So right now on page 132, you have 2 options. There's the picture it part of it that shows what I just showed with where we drew a picture of Nadia's pictures, a picture of pictures. And then below that, there's also another option that says model it that you can use an array for. So we can also break apart our array. Malik, honey, I need you to go ahead and log off because I'm recording right now, okay?
Okay.
Thank you. So we also have our array, which has, again, 3 in each row and 1, 2, 3, 4. Oh, I think I moved on to the next problem. Yes, because it says number 7 on it. All right, but you'll notice that on page 132, you can also break apart your array. So that's exactly the same thing that I did up here. I just drew a line and I said I have 4 times 1 on one side and 4 times 2 on the other, and together I have 4 times 3. All right, let's go ahead and turn to the next page. So go ahead and turn to page 133. Number 1 says, look at the picture it. How can you multiply to find the number of photos in the diagram, and how could you find the product? So you could multiply 4 times 3. You could also add 3 4 times, which we did up here, 3 plus 3 plus 3 plus 3 to make 12. Number 2 says, look at the model it, write 2 numbers that 3 was broken into to help solve the problem. So we broke it apart into 1 and 2, which together would make 3. And number 3 says, what 2 multiplication equations could you then use for the 2 smaller arrays? So we had 4 times 1 is 4, 4 times 2 is 8. Together, 8 plus 2 would, or I'm sorry, 8 plus 4 would still give us 12. All right, so we're going to go ahead and skip the rest of those problems just for the sake of time. So go ahead and turn to page 134, and you'll notice that there's a lovely array, just like the array that I have here for number 7. So it says, find 5 times 3. Draw a picture and show a way to break apart the problem to find the product. Show your work. So there's multiple steps here that we're going to use to solve this problem. The first step is to draw a picture. So it's not telling us what we're using, so we can just go ahead and use that. So it says 5 times 3. So I'm going to go ahead and do 5 rows, 1, 2, 3, 4, 5. And I'm going to put 3 dots in each row. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now the next part of this question says, show a way to break apart the problem to find the product. So what I'm going to do is I'm going to take my array and I'm going to break it apart into 2 columns. Now the nice thing about multiplying by 3 is, again, you can think about it as multiplying by 1 and multiplying by 2, which you already know the answers to, and then you can add those together. So that's exactly what I'm going to do. I'm going to go ahead and circle one group, which would be 5 times 1. I'm going to circle my other group, which would be 5 times 2. Now, when we're writing out the distributive property, we'll use these parentheses to go ahead and show how we're grouping our numbers. So I took 1 and 2, and I said, I know that 1 and 2, I know that 3 is the same as 1 plus 2. So first, I'm going to take my 5 and multiply it by 1. So I have 5 times 1. Then I'm going to take my 5 and multiply it by 2. 5 times 2. I add them together to get my answer. So in this case, 5 times 2 is going to give me 10. 5 times 1 is going to give me 5. So my answer when I add them is going to be 15. 3 times 5 is 15. So you can show the problem by writing it out. You have 5 multiplied by, I did kind of the opposite here, but 5 times 2 or 5 times 1, that's going to be one part right here. I'm going to add it to my second part, 5 times 2. Then I'm going to find the product of each of these. 5 times 1 is 5, and 5 times 2 is 10. I'm going to add them together to get my total answer of 15. All right, now it's your turn. I would like for you to please go ahead and do number 8 on your own. And when you're done, we'll go ahead and go over it together. So pause the video, do number 8. Don't worry about doing number 9. Do number 8 on your own, and then restart the video to check your answer. All right, now that you have completed number 8 on your own, we're going to go ahead and review. So the problem says Kathy set up 9 tables. So hopefully you circled 9, because remember that's our strategy for finding information quickly and easily in a word problem, is we're going to circle the numbers, underline the question, and box in keywords. So Kathy set up 9 tables, 9 is circled, with 3 chairs, 3 is also circled, at each table for a party. How many chairs did she use? So go ahead and underline how many chairs did she use. Now, the key word here actually isn't in our question. The key word here is each, because we know that we are setting up 3 chairs at each table. For every one table, there's going to be 3 chairs. So I'm going to start by drawing a picture. So I'm going to draw a picture of the 9 tables. Barely had enough room. And then I'm going to put 3 chairs at each table. Now, you could go ahead and take the time to draw out a chair but I'm not going to take the time to do that because remember, we're dealing with math and not arts right now. So I'm just going to have an X that represents the 3 chairs at each table. So I have 1, 2, 3 chairs here, 3 chairs here, 3 here, 3 here, 3 here, 3 here, 3 here, 3 here, and 3 here. Okay, so now I have my 3 chairs at each table. Now I'm going to go ahead and add them up. And the way that I can do that is I'm going to say I have 3 plus 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 3. And I should have 3 9 times. Let's go ahead and double check that I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm adding 3 9 times. So I know that 3 3s make 9. So I'm going to go ahead and find all the ways that I have 3 3s. So now really I'm simplifying my problem. Say I have 9 plus 9 plus 9. Oh, I have 9 3 times because order doesn't matter when we multiply. So now I can go ahead and add them up. I know that 9 plus 9 is 18 because that's a double fact. And then I'm going to count on 9 more to get my answer. So 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So my total answer for number 8 is going to be 27 chairs. All right. Skip number 9 because we have a lot to get through and I want to make sure that we have plenty of time. So go ahead and turn past pages 135 and 136. We'll be doing those as practice. And go ahead and turn all the way to page 138. And I'm going to move my camera down for our new problem on page 138. So last time we were dealing with Nadia's pictures. Now Jenna is making a quilt. So we have Jenna's quilt. Jenna is making a quilt. She cuts fabric squares and decides to make the quilt with 5 rows of squares. Each row will have 4 squares. How many fabric squares will she need to make the quilt? So the first model, it says that you can make an array to understand the problem. You can also break apart the array to show simpler facts. The red line shows one way to split the array. So I've done the same thing here. I have 1, 2, 3, 4, 5 rows. Each row has 1, 2, 3, 4 squares in it. I'm going to put a nice line right down the middle and say that really if I have 4, it's like I'm saying I have 5 times 2 here and 5 times 2 here because 2 and 2 make 4. So I've written it out with my distributive property using those parentheses. I have 5 times 2 plus 5 times 2. Now what's nice about 4s is they're like doubles. So we know our doubles facts from 2s, right? 5 times 2 is like 5 plus 5. So we know that that's 10. But then we just have it again. Then we just add it to itself. 5 times 2 again is 10. 10 plus 10, we're going to get a total answer of 20. Now for the second model, it says you can also turn the array around to show another fact. So I've taken my array up here and I've just tilted it on its side. You can tell because now I have, instead of my 3 rows here and my 2 rows here, I have 3 rows here and 2 rows here. I've just taken it and tilted it over on its side. So now instead of having 5 rows, I have 1, 2, 3, 4 rows. And in each row, I have 1, 2, 3, 4, 5 squares. So instead of having 4 times 5, you can also think of it as 5 times 4. And we know that with 5s, I can go ahead and skip count to find my answer. So I can have 5, 10, 15, 20. I've made 1, 2, from this one, 1, 2, 3, 4 jumps. So my answer would be there's 20 squares total in Jenna's quilt. All right, go ahead and turn to the next page. On page 139, number 1 says, look at the 2 smaller arrays in the first modelet. What 2 facts are shown by these smaller arrays? So remember, we had 2 arrays when we split it down the middle with our line. they each show 5 times 2. So we have 5 times 2 plus another 5 times 2. Number 2 says fill in the blanks to show how the smaller arrays can be used to find 5 times 4. So 5 times 4 is equal, so what they have written is 5 times 4 is the same as saying we have 5 times 2 plus another 5 times 2, or 10 plus 10 to make 20. Number 3 says look at the second modelet. What new multiplication expression is created by turning around the array? So instead of having 4 times 5, we now have, or I'm sorry, it says how are the factors alike and different from 5 times 4? So we could have 5 times 4. If we flipped it around, we would have 4 times 5. But we know that order doesn't matter when we multiply, so we would still get the same answer even though our order is different. All right, we're going to go ahead and skip numbers 5 and 6 and head on over to numbers, the next page, and we're going to do numbers 7 and 8 on page 140. I'm actually going to have you go ahead and do those 2 problems on your own. So pause the video, and then when you're done, come on back and we'll check your answers. Okay, now that you've completed numbers 7 and 8 on your own, we're going to go ahead and go over them together. Number 7, show how to find the product of 3 times 4, breaking apart the problem and also by changing the order of the factors. Show your work. So we're going to show the problem 2 ways. The first one says that we're going to break it apart. So first I'm going to start with an array showing 3 times 4. So I'm going to have 3 rows. And each row is going to have 4 in it. So I have 3 rows. Each row has 1, 2, 3, 4 in it. So 1, 2, 3, 4. 1, 2, 3, 4. Now, one way that I could show this by breaking apart the problem is I could show that I'm going to circle 3 times 2. And then I'm going to show my other 3 times 2. And then I'm going to add them together. So then I would be coming up with 3 times 2. That's like my double stack, 3 plus 3, which is 6. And then over here is 3 times 2 as well. So I'm going to just be adding another 6. 6 plus 6 would give me a total answer of 12. Now we're going to go ahead and write the problem in a different way. And the reason we write problems in more than one way is because that gives us a way to check our answer to see if we're right. So now I'm going to go ahead and think about tilting that array. So I started off with 3 rows of 4. Now I'm going to go ahead and do 4 rows of 3. So I have my 4 rows. I'm going to put 1, 2, 3 in it. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so now instead of thinking that I have 3 times 4, I have 4 times 3. I have 4 3 times. I could also think about that as have 4 times 2 and 4 times 1. 4 times 2 plus 4 times 1, because 2 and 1 make 3. So 4 times 2 would be 8. 4 times 1 would be 4, and when I add them together, I get 12. Same answer, so I still got it the same way both times. All right, now for number 8. Number 8 says break apart the array to find 9 times 4. Fill in the blanks to show your work. So they already gave you an array, and you are going to go ahead and break it apart. Now, you could break it apart in any way that you want. If you have 9 times 4, I would highly recommend doing 9 times 2 plus 9 times 2, because then you cut your work in half because you're only finding the product for 1, and then you're just doing it again. But you could also do it as 9 times 3 plus 9 times 1, because 3 and 1 are also another way to make 4. So let's go ahead and stick with splitting it right in half. We have 9 times 2. I know that that's a double stack, so I'm going to get 18 here. I have the same fact over here, so I'm also going to have 18. When I add them together, I'm going to get a total. 8 and 8 is 16. I have 1, 2, 3 tens now for a total of 36 for number 8. All right, go ahead and turn past, once again, we're going to skip number 9. Turn past 141 and 142, our practice pages. And we are actually going to skip over pages 143 and 144 and 145 and go directly to 146 to give you a little bit more practice. So again, we're going to skip the last problem. We're just going to do the first 2. So number 6 says, show 2 different ways to break apart 3 times 6. So again, you can do this in multiple ways. It says, draw the models and write equations for each model. Show your work. So one way is we can come up with an array that has 3 rows. And in each row we have 1, 2, 3, 4, 5, 6. In each row. So one way that I could break up my array is to, once again, just split it directly in half, and then I have 2 groups. I have 3 times 3 over here, and 3 times 3 over here. So I could think of that as 3 times 3, 6, 9, plus another 9 gives me a total of 18. Or let's go ahead and split it a different way. I'm going to use my same array, but I'm going to erase the lines showing how I divided it that first time. And this time I'm going to go ahead and say that I have 1 group here, and I have a group of 5 over here because I know my 1s and my 5 stacks already. So I could say I have 1 times 3 over here, and then I have plus 6 times 3 over here. Oh, wait, sorry. I do. I wanted to read that. So I have 1 times 3 over here. But then over here I have 1, 2, 3, 4, 5 times 3. 5 and 1 together make 6, so I'm still dealing with the same array. I know that 1 times 3 is going to be 3. 5 times 3, I can count by 5. 5 times 15. Now I have 3 plus 5. I'm sorry, 3 plus 5 ones would be 8 ones, and then add 10 more to it to make it 18. So 3 plus 15 is 18. So I still got the same answer in a different way. Now, there are multiple ways that you could have broken apart your model. So if you got something different from what I got, that's okay. As long as your factors that you break your array apart into add up to your original number. So in this case, I have 1 and 5. 1 plus 5 still makes 6. Any way that you can make 6 is going to be a viable way for you to go ahead and break apart your array. All right. Number 7 says find 5 by 6 or 5 times 6 by breaking apart the 6. Show how you broke apart 6 on the array. So again, every time we have 5 times 6, I'm going to go ahead and draw 5 rows, each with 6 dots. Again, there's lots of different ways that you can go ahead and break apart this array. So you may get a different answer from what I got. But if you're stumped, you can go ahead and watch how I break apart the array and then do it that way yourself. All right, so we're dealing with the fact 5 times 6. Now, once again, we can think about I have 5 1 time, and then I have 5 times, right? Because I know my 1 stacks and I know my 5 stacks already. You can also break it directly in half. You say I have 5 times 3, and I have another 5 times 3. Because 3 plus 3 would make 6. So you can do this in multiple ways. You could also, say you have 4, 5 times 4, and 5 times 2. Let's go ahead and use that model. So I'm thinking of 6 times 4 plus 2. I'm going to multiply my 5 times 4 and my 5 times 2. I'm actually going to start with 5 times 2 because that's a double stack. I'm going to say I have 5, 10. So 5 times 2 is 10. I know that my 4s are really like double doubles. So I'm going to say, what's double 10? 10 plus 10 would be 20. So 5 times 4 would be 20. And I can double check that using my finger method by counting by 5. 5, 10, 15, 20. Yep, that checks out. So now I have 20 plus 10. There's 30 dots in this array. Okay, but I chose to break apart the 6 by thinking of it as 4 plus 2. So the last thing that we're going to do, first of all, the next 2 pages, 147 and 148, we're also going to be covering in our math lesson tomorrow on Tuesday. Pages 149 through 152, you're welcome to do practice because as we all know by now, multiplication is super duper fun, and so you may just not get enough of it. But before we move on, I do want us to go back to our multiplication chart because we already learned some new facts today. So let's go ahead and fill in our chart. So we have 3s that we talked about today. We know that we can count on adding 3s each time, but we also know that we can think of it as 2 and 1. So breaking it apart into thinking what's the double stack and then adding that number again. So if I had 3 times 3, I could think of that as 3 times 2 is 6. Add one more group of 3s. So 6, 7, 8, 9. Add 3 more again to 9, 9, 10, 11, 12. 12, 13, 14, 15. 15 is already written in, but we want to check it out to make sure that we've got that right. So 3 more than 15, 15, 16, 17, 18, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26, 27. And lastly, I should get up to 30, 27, 28, 29, 30. Check that. I'm going to do the same thing down my row here. 12, 15, 18, 21, 24, 27, and 30. All right, but wait, that's not all. We also learned 4s today. So we have 4 times 1 is 4, 4 times 2 is 8. Now we have 4 times 3 is 12. I'm going to add 4 more to 12 to get me 4 times 4. So 12, 13, 14, 15, 16. 4 more should get me to 20. Let's double check that I did it right. So 16, 17, 18, 19, 20. Yes, that checks out. 20 plus 4 more is going to get us 24. 24 plus 4 is going to give me 28. 28, 29, 30, 31, 32, 33, 34, 35, 36. Again, double checking, 36, 37, 38, 39, 40. Yep, checks out. And then let's go ahead and fill in our last row. So 16, 20, 24, 28, 32, and 36. Look at how many math facts you already know. Now you may also notice in your multiplication chart, one further benefit is that you can start seeing patterns. So when you have 4s, you have 4, 8, and then in the one space you have 2, 6, 0, and then it repeats 4, 8, 2, 6, 0. You'll also notice that with 5, we alternate in our one space 5 and 0, 5, 0, 5, 0, 5, 0. So there's lots of fun hidden patterns that you can also find out in your multiplication chart. All right, I will see you guys on Tuesday for those practice pages, and we will go ahead and continue filling in our multiplication chart as we continue to learn our multiplication facts. So hang on to your multiplication chart because we will continue to fill that in as we continue to work through the facts. All right, see you guys tomorrow. Have a great afternoon. Bye.